Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
Alrighty, now we begin chapter 3. Lesson 3.1.1 is entitled Grouping Expressions. And this particular lesson is a lesson where we're going to kind of review the order of operations, PEMDAS, and why we do what we do in the order that we do them. But it's also going to present a different strategy that one can use, which is related to PEMDAS, but not exactly the same, but it still works. You're still following the basic principles of PEMDAS, but it just looks a little bit different when you're simplifying. So let's get to it. First, we've got some different terms here. We're going to spend a little bit of time putting in some vocabulary, just so you know when I refer to these, you'll know what I'm talking about. So let's start with the numerical expression, and the numerical expression is a mathematical statement. But it only contains numbers and operation symbols. I'm not talking about a variable expression or an algebraic expression that has an unknown quantity. We'll get to those later. For now, we're just going to focus on numbers and operation symbols. So an example of a numerical expression would be like 2 plus 3. Well, we know that's 5, right? So it's just numbers there. It could get more complicated, though. It could be 5 squared times 2, parentheses, 1 plus 3. That has operation symbols and numbers and parentheses, and that is a numerical expression. A numerical term is a part of the numerical expression that is being added or subtracted from another part. So if I took this, once again, 2 plus 3, we've got two terms here. Here's a term that's being added to that, okay? If I take, let's see, 2 squared plus 4 times 3 minus 5, then I'm looking for my plus signs and my minus signs that are not surrounded by parentheses like this guy right there. So here's a term. Here's an example of a term, and here's an example of a term. Now, one thing that's kind of interesting, I'll do this guy right here, just rewrite it, 5 squared times 2, parentheses, 1 plus 3. This is what I refer to as a complicated mess. There's only one plus sign, and it is inside parentheses and a part of a multiplication expression. So technically, this entire expression is just one term. And we would have to use the order of operations to simplify that term. We take care of the parentheses first, then do the exponent, then do the multiplication from left to right. Simplify is a term that we use when we need you to use the order of operations or whatever strategy you like best to rewrite the numerical expression so it only has one term. So if I take 2 plus 3 and I simplify it, it's going to be equal to 5. So this is the simplified version of that expression. Okay? If I take this guy, that becomes a 4. This is a 12. And then minus 5, when we simplify that, it becomes from left to right, 16 minus 5 is 11. So when you just write it as one term, you have simplified completely the numerical expression. And while this particular lesson is not focused on the order of operations, PEMDAS, if you will, it does sort of lay a foundation for why we do the order of operations in the order that we do them. So I've written it out like this. It would be good, to write these down. So maybe go ahead and copy it the way that I've put it here. Okay. So parentheses has the highest priority, and it's not just parentheses. It's any kind of a grouping symbol. So parentheses look like this, but they can also look like this, and I think those are called brackets, braces. I honestly can't remember the term, but we've got 3 different looking parentheses, and so it's very helpful if you have parentheses within the parentheses to switch it up a bit, not just use the typical kind of arcing sort of lines that we use for our typical parentheses. So any grouping symbols. Now, it turns out that the square root symbol is a grouping symbol, and the fraction bar is also a grouping symbol. So parentheses applies to any of the grouping symbols. It's not just this right here. Exponents, that's when you have a base and you have a little number in the upper right-hand corner, that's the exponent. So this, which is technically repeated multiplication, it's equal to 3 times 3 times 3, has priority over multiplication, division, addition, and subtraction. This, when there's no parentheses to be found anywhere, has the highest priority. Then multiplication from left to right. That's the key, left to right there. Multiplication and division, just because the M comes before D and PEMDAS doesn't mean multiplication has a higher priority than division. If you had the problem 15 divided by 5 plus, no, times 2. Some people want to do the multiplication first and say 15 divided by 10 is 1.5. But from left to right, you must do the division first because it shows up first. 15 divided by 5 is 3, and 3 times 2 equals 6. So this expression is equal to 6, okay? Addition, subtraction works the exact same way. This is such a common mistake where people see 12 minus 3 plus 4, and people think that you're going to take 12 minus 7, which is 5. But that is not the case. Addition and subtraction are equal partners of each other. So you must go from left to right. So this becomes 9 plus 4 is actually equal to 13. Okay? I think 13, 9 minus 3, no, 12 minus 3 is 9, and 9 plus 3, yes, 13. 16, John, that's right. Later on, I'm going to show you, probably this chapter, about how rather than having subtraction in here, how we can rewrite this as 12 plus a negative 3 plus 4. And if you rewrite this as only an addition problem, then you'll see that you can actually add them in any order that you want. So you could say 4 plus negative 3 is 1, and 1 plus 12 is 13 also. But here, you wouldn't be able to add the 4 and the 3 to make that a 7, because that minus sign means that has a value of negative 3. And if you just think about Cecil walking on the tightrope, remember how we went backwards when you had a minus sign? Well, plus a negative 3 means a 3-step backward move and then a 4-step forward move for the plus 4. So we'll get more into that. We'll reflect on how Cecil worked with his tightrope in helping us understand why we do what we do. All right, in previous lessons, you have worked with expressions, combinations of numbers, variables, and operation symbols that involve either adding integers or multiplying integers. Today, we will examine expressions that involve both operations. By the end of this lesson, you'll be expected to be able to answer these target questions. How can expressions with the same numbers and operations have different meanings? And does the order in which we do each operation matter? You know the order matters because you've learned about PEMDAS. All right, so here's a stoplight problem. Let's see where Katrina is struggling a little bit. I'm assuming she's struggling because there's a stoplight, right? Okay, so Katrina wrote the following set of instructions for Cecil. 4 times 2.5 plus 1. If Cecil, the acrobat, follows Katrina's instructions, how far will he go? Your job is to draw a diagram of Cecil's movements and show how far he will move, okay? I'm going to read through all these directions, and I'm going to ask you to pause and try and figure out every single one of them, and then we'll come back and I will show you my answers. Katrina drew the diagram at the right here. 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1. How was she thinking about Cecil's moves? Write an expression to represent what you think she thought Cecil was supposed to be doing in a numerical expression. Okay. Actually, you know what? Why don't you pause right now and just take care of parts A and B? Because I have a feeling it's going to get a little confusing if we move on without addressing these two parts first. So go ahead and pause and and take this and draw what you think is supposed to be the diagram and how much it equals, and then what this diagram is actually representing for Katrina. Okay, welcome back. So if it's 4 times 2.5 plus 1, then literally he takes 4 steps of 2.5 and only 1 step of 1, correct? So 2.5 plus 2.5 is 5. Another 5 makes 10, so this should have a total value of 11. So he would move 11 feet if he followed these instructions here. All right, do we all see that? Repeated addition is multiplication. So 2.5 plus 2.5 plus 2.5 plus 2.5 is 1. So when Katrina drew this, I don't think she had that in mind. What do you think she had in mind? She was thinking that he would move more like 4 of the 2.5s and 4 of the 1s. So we could put parentheses around this. And so it could be 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1 plus 2.5 plus 1, or we could write the shortened version like that. So explain why Katrina's diagram in part B will not give her the correct length for this expression. Go ahead and pause and write down why you think that is, and then I will share my response. Have a little sip of coffee while I'm waiting for you. Delish. Okay. So you've unpaused. I'm sure you did not hear. Well, I guess you would hear me, wouldn't you? Okay. Okay. So this expression contains 4 ones, but not this one. This one only contains 1. So see how this diagram fits with what she's got written there, because there's 4 of the 2.5s, but it's only supposed to be 1 1, not 4 of them. So Cecil changed Katrina's set of instructions so that the length of 1 foot came first, as shown here at the right. So you see how that's 1 plus 2.5 plus 2.5 plus 2.5 plus 2.5. So if we were to write what that would look like, we could say it like this. Instead of saying all of these added together, just do the repeated addition as multiplication. So 1 plus 4 times this quantity. Now remember order of operations. This is not 5 times 2.5. You cannot add before multiplying with the order of operations. You must multiply first. So you've got this 1 being added to these 4 2.5s that are being repeatedly added together. And we still end up getting 11 feet, right? So does it give the same distance? Yes. It is the same length as written this way. Okay? All right, so Cecil's tray. Ooh, I didn't want to show you all of this. Boo. Okay, whatever. I'll just do it for you. Forgot to cover it up. Okay, Cecil's trainers proposed each of the following movements. Which one requires the longest rope? All right, so what I did was I started off with A, and what I did was I basically took those distances right there, an 8-foot distance. So I'm like using these equal portions here as 2 feet each, right? There's 2, then 4, then 6, and 8, and that's a little bit past the 6 mark, between 6 and 7. So if we use that, and they're properly scaled, 8 plus 2 times 6.48 means he's got 1 step of 8 and 2 steps of 6.48. If you have 2 plus 8 steps of 6.48, then here's your 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So you can clearly see that routine B is longer. Wait, is this, yeah, or the rope. We're talking about the longest rope that would be needed. The rope for B, it has to be longer than the rope for A. Now, they didn't ask us to actually declare what the value of, or what the length of these ropes are, so I didn't include that. So we're just going off the visual, okay, not the number. And then 8 plus 2 times 6.48, normally the addition would have the lowest priority, right? Here, the multiplication had the higher priority than the addition. So we did 8 of those plus the 2, and it didn't really matter the order, just like on the previous page. Here, The parentheses is telling us we're giving the highest priority to the addition. So we have to do the 8 plus 2 first to make 10 steps of 6.48 feet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can clearly see that C gives us the routine or the part that requires the longest rope or the most rope. All right, so now we're going to get into the CPM version of order of operations, where instead of following PEMDAS, we circle terms. And you may recall the terms are the parts of a numerical expression that are being added together. So let's read through this and see if we can make sense of it. The expression 5 plus 3 times 4 plus 2 can be represented by a group of tiles as we see at the right here, okay? So it says work with your team, but you can just look at this. Please copy that down. And what it wants us to do is connect this expression to this diagram. So you notice this grouping right there, how we have 5 pluses, 5 positive ones there. That's this part right here. How we've got 1, 2, 3, 4 positives in this row, but we've got 3 rows of them, which is the 3 times 4, and then you've got these 2 right here. So we could kind of show it in these terms. So notice how this says 5 plus 3 times 4. We need to know this section right here. We need how do I want to word this? There's in no situation does it show us taking 8 times 4, correct? So this represents just 5 on its own. That's being added to 3 groups of 4, which has been added to a group of 2. So these are considered the terms of that expression. So each group of positive tiles is represented. Oh, I never uncovered how many tiles there were, but all you have to do is count them, right? 19 tiles. So when we simplify this expression, 5 plus 12 plus 2, you're going to get a total of 19. Okay, so each group of tiles is represented by a different part of the expression called numerical term. Numerical terms are single numbers or products of numbers. It is often useful to circle the terms in an expression to keep track of the separate calculations. For example, each term circled in the expression below here represents a separate part of the collection of the positive integer tiles that we saw up here. So the 3 times 4, that is a single term, right? It's the product of some different numbers. The number 5 is being added to this product, which is being added to the number 2. So this expression has 3 different terms, okay? Now, if you circle the terms, you can't add the 5 to this term until you've done the multiplication, correct? And changed it. Did I say 14 there? What am I doing? It's not 14. What's it supposed to be? This is the part when I'm teaching when a bunch of hands go up and I'm like, put your hands down. I'm not ready for questions yet. And then the hands persist. And then we start to realize, oh, I must have made a mistake somewhere. Okay, where's my mistake, people? And then I fix it. And I deny that I ever made the mistake. Okay, so that's what it's supposed to be. All right, so now we've got this expression. Please copy down this expression. 4 times 5 plus 1 plus 3 times -2 plus 6. Our job, or your job, is to circle the terms. So remember, the terms are the parts that are being added together. So I'm going to highlight the plus signs in here. And that's technically not a minus sign because it's attached to the 2, so it's telling you it's -2. It's also inside parentheses, which we'll get to in a second, and there's something that I call complicated messes. And we'll explain, I think, on the next page why we would not consider the 3 and the 2 separate terms. They're a part of one multiplication process, okay? So when we circle the terms, that would be the 4 times the 5 is a single term, the 1 is a single term, the 3 times the -2 is a single term, and the 6 is a single term, okay? So when we want to draw, or why don't you go ahead and draw what you think is the right configuration of tiles, like we did up here, and see if yours matches mine. Go ahead and pause. And remember, if you get it wrong, you can cross it out and copy or erase and copy down what I put down. But it's always better to try and see if you understand it on your own first and not just wait for me to write it down and copy me. Trust me, your brain is going to learn this information faster if you take the initiative and try and figure things out first and be okay making mistakes. As long as you recognize after seeing what the correct answer is, where your mistake was made and you fix it, you're going to be learning, okay? Okay, so let's see what I've got here. So this is 4 groups of 5, right? This is just a single 1 being added. This is 3 groups of -2, and that's just a single 6 that's being added. So here are our 4 groups of 5. That's a total of 20. Maybe I'll write this down. And I'll do it in blue. So this is 20, right? And then there's just a single 1. And then there is 3 groups of -2 for a total of -6. And then you've got 6 right here. So you notice how these all cancel out. They make a 0 pair, which leaves you with a total answer of 21. Okay, so we're pretty much following the order of operations here. We're doing the multiplication first here and here before we're doing any adding. Technically, you could have added the 1 to the 6 first, then multiplied these guys, and then added the 7 to the -6 to the 20, and you still would have gotten 21. It just wouldn't have looked quite like order of operations. So it doesn't always. All right, so here is your, is it your second to last page? No, it's not. I guess we got a little work to do here. All right, so what I would like for you to do is copy each one of these expressions down. Then I want you to circle the terms. Identify how many terms there are in each one of those expressions, and then simplify and write down the answers. Okay, I'm going to pause too because I'm going to take my little break before moving on. You go ahead and do this work. You pause it, and when you come back, I'll have everything circled, and then we'll go over the answers. Alrighty, so taking a look at the work, you notice there are plus signs here. Let me just go ahead and do that little highlight there. So the terms would be the 7.08, the 2.51, and the -3.84. When you add all those together, you should get an answer of 5.75. Here, our terms are what's being added together. The 7.8 is being added to the product of 2.1 and -3. So that's a multiplication problem. That minus sign is attached to the 3, and it's a part of a greater multiplication problem. So this is all considered one term, that entire multiplication problem. When you add, when you multiply here and then add together, you get 1.5. Here, you've got 2 terms, just like you had for problem B, where you've got this multiplication problem. Once again, that minus sign is attached to the 3/5, which is part of a multiplication problem. And then once you figure out what 5 times -3/5 is, then you can add that to this multiplication process. Oh, I should have probably mentioned this. Well, no, I guess you probably would have figured it out. This is 2 times 1.5. So when you do that, you get an answer of 0. So it's 2 times 1.5 is 3. And 5 times -3/5 is -3. When you add -3 to +3, you get 0. And then we've got a few multiplication processes in here. Here's a multiplication process being added to a 5, plus there's a multiplication process being added to a -10. So you got a total of 4 terms in this entire expression. And when you do all the work, you end up with 0.45. I'm assuming most of you probably changed this to 3.25 rather than changing that to a fraction. Probably would have been easier to do your calculator and change that to its decimal form. Okay. All right, now for the challenge. It's a group challenge, but you're on your own. So this is what I want you to do. We are going to take this. Oh, stop it. Give me the big. There you go. Take this expression right there. Write it down 2 different times. Give yourself a little bit of space. So Your task is to use parentheses in a way. So you're going to add parentheses to make the smallest possible value, and then you're going to do the exact same thing so that you can create the largest possible value without changing any of these numbers or any of those operation symbols. Remember, the parentheses in the order of operations has one purpose and one purpose only. It is to give priority to a lower priority operation. Addition and subtraction have the lowest priority, but if we wanted to have a higher priority than multiplication, for whatever situation we're working through, we will put parentheses around it, and the parentheses automatically move it up to the highest priority. Okay. So copy down this expression 2 different times and see if you can identify the lowest possible value of this expression when you put in the parentheses and the highest possible value when you change the location of the parentheses. Go ahead and pause, and when you're ready, you can see what I did. All right, so let's start with the lowest possible priority. I'm sorry, did I say priority? The lowest possible value. If we just, technically you don't even need to put the parentheses around the 3 times the 2, because that's the only multiplication happening in this entire expression. The multiplication already has the higher value than any of the addition or subtraction parts, if you want to treat this as -4 instead of plus and -4. So putting parentheses around it, we're actually not even changing the expression. You would still do the multiplication first, but then add from left to right. 7, 15 plus -4 is 11. Okay, so that's the lowest value you can get out of that expression. Now, what's the highest value we can get out of that expression? Well, if we give the priority to adding 1 plus 3 and adding 2 plus 8 before we multiply those two together, that's going to significantly change the value, right? Because 1 plus 3 is 4 and 2 plus 8 is 10. So now, after we've done that, we've got 4 times 10, which has to be done before we can add the -4. So 40 plus -4 gives us 36. So simply by adding parentheses in these 2 locations to give the addition the higher priority than the multiplication, we have changed the value of the expression. Okay, so what is the whole point of order of operations? The order of operations gives the highest priority to exponents or exponent operations. We're not really working quite yet with exponents, but we'll work with them more in 8th grade. Then it gives the second highest priority to multiplication and division. And remember, they're equal partners, and you would move from left to right. Addition and subtraction always have the lowest priority, unless if you want to give a lower operation the highest priority, you must surround it with parentheses, okay? So I highly recommend you write this in, treat it like it's a poem or something, maybe write a song to it. I'm sure it has a nice ring to it. But this is what you need to understand about the order of operations. It's not like some mathematics council somewhere in the world 100 years ago decided to make PEMDAS. There is actual logic and reasoning in the universe for why we do things in this order. Okay, so good luck on everything. Do your homework, and we're going to move on to lesson number 2 soon, if not tomorrow, early next week. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,